Again, this is Dara at CCN Studios. I'm back talking about the PDB molecule, biomolecule 2. Let me just make sure I have the name right. 2A1Z for a good doctor Jaya in Indonesia and Tahir in our organization, who he does the productions and lots of beautiful design works. And Tahir had an idea to kind of do some videos and, as he said correctly, nerd myself into these molecules. Okay, so we are on Unity version 6.2.0A1, which is the latest post-beta release. I believe February 2025. Today is March 13th, 2025. So this is pretty hot stuff from Unity, and our core emphasis here is to work with one of the top 3D engines, see if we can use it for molecular research and development and education. Okay, so this molecule over here has no colors. To my surprise, I downloaded it from a PDB data structure database over the net, and it's easy to add the colors. By this point in time, I just want to travel through it. So you understand that the chains that we were talking in the previous video, for example, here, where I will tell you the chains are here. These are the chains. As you were, this is the chain A. As you were seeing before, the reddish highlighted, see that? The reddish highlighted ribbons actually with directional arrows on them, as you can see. These don't exist in nature. It is for the biochemists to figure out something about orientation of these ribbon surfaces made a lot of out of atoms and polymers. And then I'm gonna switch to the second, the B chain, and that's the B chain over there. And then the C chain. Let me see. Yeah, precisely was up there. That is the Chi chain. Okay. And then just 1 minute, please. Let me turn off some stuff. Okay. And then D chain was another one of these polygonal looking things. All right. So let's go back to the A chain. It's beautiful. So I was thinking, I was just speaking to Tahir that I was saying that I'm probably Dr. Jaya would not like it. But I was thinking to color these per scientific documents that we have on the molecule. And then I'll add my mesh sticker algorithm, which in cooperation with Mr. Gregory Labou at Unity we have developed last year, where the characters stick to a mesh, assume gravity changes direction, so they're always vertical to the surface of the meshes. And we walk through these molecules, and I'll just talk about the computational aspects of the molecular structures as found in the research papers by lab scientists who have discovered this. So nothing I will make up or read some funky magazine someplace. It will actually be what they wrote in their papers, best I understood. Sometimes if I don't understand, I email them, and of course they will ignore us. That's just the nature of this modern scientists are. And I think Tara was right. He had a good idea. Look how beautiful these structures are. How could you go wrong? Oh my God, look at this. Let me see if I can use let me just select the whole thing. It's a little bit difficult to move it. I don't know why, because I'm recording the screen. I have a very inferior screen recorder. And at any rate, so the other thing I want to add is computational photography which would allow us to have something, a vehicle or a drone, fly through the molecule or walk on the molecule, any which way you envisage this, or just an invisible orb that you can fly through. Tahir and I have done this in the past many times. It's a lot of fun and it's a beautiful videos it generates. But when it flies through the molecule, then what it does is that it will take photographs, digital photographs inside the Unity engine, and then it would stream the photographs, high resolution photographs, to our servers, to our CCN's cloud servers. And these photographs will be like souvenirs from traveling through the protein called, sorry again, 2A1Z. So anyway, so let me see if I can zoom out, and I'm trying to zoom out of here. I don't think I can. I'm stuck here. Oh, I can. Let me see. Nope, I got too much zoomed in. Yeah, here we are. Let me go closer. Back here again, get rid of the axis. Look how beautiful this is. This molecule, polymer, gene, whatever scientists consider this, exists in every cell of your body, of every human being, probably in a lot of animals and plants. I mean, give this a thought. I mean, the numbers, we are out of acronyms and vernaculars for large sized numbers to describe how many times a second this molecule gets created and operates within the cells of creatures living on this planet only. And just to tell you that how amazing this is that they don't fail. These are incredible machines. Wait till I color this. I think Tara will be very excited. We travel through this just like this, make some videos and have fun. I can add computational geometry, differential geometry. We can add electrostatic fields for this, the whole bunch of information that they would drag you to a classroom. You don't want to learn it, but we try to make it more interesting. And I like to thank Tara for his good idea and Dr. Jaya for getting us on this track so we can play. So in my next video, I've dyed and colored these. And then we do some other fun computational things so everyone can have access to them. And that will be putting this into our nodule construct, our very advanced cloud-based Unity application for 3D interactive applications. I love that. Look at how beautiful that is. And take it from there, see what happens. At any rate, thank you for your time. And Tar, thank you for your idea, and thank you, Dr. Jaya. I think I finally find the calling for my life, as the Americans say, finally. At any rate, this was a very low production, rough video, and I think, as Tahir depicted the idea in my head, it's okay if it's low production. I don't think police would arrest me. Thank you very much. Bye-bye.